denominator means that we want to eliminate a radical from a denominator. So here we have the square root of 13 over 28, and we have our quotient property of radicals that tells us we can separate this into the square root of 13 over the square root of 28. And here's where we have a radical in the denominator, and that's a problem. In math, we can't leave an answer like that. What I do notice about the square root of 28 is that that's a radical we could simplify. So if we remember our perfect square numbers, 4, 9, 16, 25, 36, I actually could stop at 25 for this one because 36 is too big. Do any of those perfect square numbers fit into 28? And 4 does. So I'm going to simplify this because it'll leave me with a smaller radical to rationalize. So we have the square root of 13 over, now instead of the square root of 28, this breaks apart into the square root of 4 times the square root of 7, because 7 times 4 is 28. Then the square root of 4, we know that is 2. That's the whole reason why we broke it apart this way, because we know what the square root of 4 is. So the square root of 4 times, or square root of 4, which is 2, times root 7. Okay, so now our denominator, that radical is simplified. Now to rationalize the denominator, what we want to do is we are going to multiply the radical by itself. So what that means is the radical right here is the square root of 7. That 2 is okay. I'm going to leave that where it is. But I'm going to rationalize the square root of 7, which means multiply the radical by itself. So I am multiplying right here. And if you notice, anytime that we multiply the bottom of a fraction by something, we always have to multiply the top of the fraction by something. So now we have the square root of, I can bring this 13 times 7 together over 2 times, now square root of 7 times square root of 7 is equal to the square root of 7 times 7 together, that's our product property, which is the square root of 49, and we know what the square root of 49 is, so that is 7. So back up in our problem, we have 2 times 7, this pen is driving me crazy, 2 times 7, and we can do 13 times 7 is 91, so we have the square root of 91 over 2 times 7, which is 14. And then the last thing we want to think about is, can the square root of 91 be reduced? You know, do any of those perfect square numbers fit into it? And they don't. So our final answer is the square root of 91 over 14.